So the last page about properties of circles, we're going to be looking at the sectors now and the areas of those. Again, it's kind of like the idea of a whole circle. If I want a portion of a circle, I want the area in here, I can take the area of a whole circle and divide it by the portion I want. We know a whole circle is pi r squared, so if I take that and I use the idea of the central angle, the portion of 360, I get this equation right here, right? We have the portion of 360, the portion of the circle, and then the area of the whole circle. Again, another version of that, we can put all the multiplying on top and divide by the 360. We can solve area, we can solve radius, we can solve angle, just like we did the last one. Let's look at the first one here. So I'm using my equation, my big A for area equals pi r squared theta out of 360. Okay, my area part times my angle part out of the total 360 degrees of the circle. In this question here, we have pi. Our radius is 10.2. The central angle between the two radius is 100 out of 360 degrees. Put that all in our calculator and we end up with 90.79 centimeters squared. If you want to try the second one, give it a try. Okay, we're looking for something a little different that time, but see if you can figure it out. Okay, same equation, just a different way of approaching it. In B, A equals pi r squared theta out of 360. Here we're told the area 5.1. Pi is pi. The radius we were told is 4.8 squared. We don't know the angle this time, but we still know it's out of 360. Kind of looks like the last example we did on page 2, where we can work with some of the numbers at a time. 5.1 is 5.1. We can do all this math at one time, and we'll attach the theta to it. And if we do that, we end up with 0.2011 with a theta attached to it, okay, which means we can divide out the 0.2011 and the 0.2011, and we'll end up with the angle, the central angle theta, being 25.36 degrees. Okay. If you want to try C, again, pause if you need to, give it a try, see if you can figure it out, and if not, keep watching. And see here, same formula. The formula is not going to change. So pi r squared theta out of 360. And what do we know? We know the area. Area is 840. Fill that in. Pi is pi. R, oh, don't know r this time. I don't know r squared especially, but I do know the central angle. The central angle is 220 out of 360. And as we said previously, we can sort of move things around a little bit if it makes it a little bit easier to think about. This is like saying 220 pi times r squared out of 360. Right? The order you multiply in does not make a difference. Okay, so 840 equals. We're going to do all the math parts where we can do the math parts, all of that at one time. We'll end up with 1.92, and it has an r squared attached to it. I want to solve this, get r by itself. So I divide out the 1.92. Okay, I'll end up with an r squared on the right-hand side here. And on the left-hand side, the number comes up to 437.5. That's r squared. We want r, so we square root it. And r comes out to 20.92 meters. And that's how we can work with sectors of circles, whether it's the radius, the central angle, or the area itself.